Now see students, after seeing the recrystallization temperature, we will again come back to the cold working. Okay, so the cold working, definitely we are going to see the both cold working and hot working. So see, the cold work component or the cold working, we are seeing one phenomena that is known as the strain hardening or the work hardening. So the cold work components, the cold work components are showing the strain hardening, or this is also known as the work hardening. So because of this, see, when the percentage of cold work is increasing, if this is the percentage of cold work, if I am increasing the percentage of cold work, we will see the increase in the properties like the tensile strength and the hardness. At the same time, of course, the toughness and ductility, as hardness and the strength increases, we know that ductility definitely goes on increasing. So see this strain hardening or work hardening. Cold work component will show this phenomena. So what is this actually? The strain hardening or this work hardening. So क्या है ये strain hardening or work hardening? So see, when the material is subjected to cold work, so in this the material become stronger and harder, so that for further deformation it is necessary to have the maximum stress or load than the previous. Okay, so if you want to have the deformation in the material, we need to supply the more amount of stress as the material is become stronger and harder. So here the stress required to cause the slip is required more in amount than the previous. So this is the cold working or strain hardening of this material. So as from the stress strain curve, it is very much clear that, see, after the yielding, see, from this yield stress up to this ultimate strength or stress into this curve, sigma ultimate, this is sigma y. So here look at this curve. So every point, so if you look at the stress, so if I take the stress as this value, so the value of stress here at point say A and the value of the stress at point B. So of course, to get the deformation into the material, okay, I need to supply the more amount of stress at point A than at point B. Okay, so this is our strain hardening region actually. So this is our strain hardening or work hardening region in this stress strain curve, and which is nothing but our what? Our plastic deformation zone. That is also very important. So plastic deformation, जितना आपको ज़्यादा से ज़्यादा deformation चाहिए मटेरियल के अंदर, so the plastic deformation zone जो है ये क्या होना चाहिए, जितना wider हो सके उतना अपने लिए अच्छा है, to get the maximum deformation, maximum working onto the material. Now see, so one thing is very much clear that because of this cold working, because of this cold working, there is a strain hardening phenomena, because we are just working on the material below its recrystallization temperature. So material is become harder and stronger, so that further deformation we need the extra maximum amount of stress than the previous one. So because of we are working below the RCT, so definitely the grains are going to distort. Microstructure, when we see for the cold work component, it will see the distorted grains, bent grains. Okay, and in such a situation, if you are go on working on the material, so definitely up to certain limit, no doubt we will have the deformation even in this strain hardening region. But after some time, when we cross the limit of say deformation, definitely there are the huge chances of the crack occurrence, the crack formation onto workpiece or into the workpiece. So that is very hazardous. Agar crack form hoga, definitely it is failed, the component is failed. So to avoid that, from stage to stage in this deformation region, what we are doing, we are removing the material from the deformation region and subject it to some process to get that material soft. To get the material soft and more deformation can be possible onto that material. So we require some suitable heat treatment process, which is nothing but the annealing. Okay, so see here, because of this cold working, because of this strain hardening, material is getting stronger and harder. So definitely maximum stresses are requiring to deform the material. So in these circumstances, what are the chances? There are the chances of the crack generation. So up to certain limit, no doubt deformation is possible. After that value, that limit, the cracks are going to form. To avoid this crack formation, what we are going to do, we are removing the material from this region and have the suitable heat treatment process which will give the softness for that material, so that we can again have the further required deformation into the material without crack. And for that reason actually we are having this annealing process. So annealing कौन से annealing में क्या क्या है यहाँ पे? It is having 3 steps. This annealing is having 3 steps here. पहली steps कौन सी है? That is recovery. That is simply we can have the stress relief annealing, isn't it? After recovery, quite at higher temperatures, again for higher holding time, we are having the recrystallization. We are having the recrystallization, and after recrystallization we are having the grain growth. These 3 steps we are having for this annealing. कौन से? So I will write it here only. So annealing is having annealing. It is suitable heat treatment process to give the suitable softness for the material. Number 1, the recovery. Second, recrystallization. And third one is the secondary recrystallization, we can say, or you can say the grain growth. The grain growth. With these processes, with these heat treatment processes, we can able to give sufficient properties, of course, for the deformation. Recovery. So it is, the temperature is quite, or it is somewhat lower temperatures. So here only whatever the residual strain or residual stresses which are into the material in the form of the energy pockets. Okay, the energy pockets, the bundles of energy because of the working, straining of these grains. So whatever the IRS, internal residual stresses which are there, we are just trying to relieve those to give certain mechanical properties for the material. Okay, so generally see, the mechanical properties are not going to get changed, but in certain amount, in less amount, the ductility enhancement is there in the recovery. it is nothing but the stress relief annealing. Okay, so temperature is fairly low and we are removing the residual strains or stress into the material because of the working to recover the properties like electrical conductivity, thermal conductivity. Okay, so these properties to the material, of course little bit increase in the ductility only, that is the recovery. We have talked about this recrystallization, the formation of new grains, the formation of strain free, stress free, equiaxed grains. This is because of the recrystallization. And when we talk about the grain growth, so the temperature is sufficiently high and we keep it for a long period of time, so grain size is increases and eventually the grain size is become more than the original size of the grain. It is known as the grain growth. Okay, so in this way we are enhancing certain properties of the material by using this annealing process, which will give us the again more region for working on the material or more deformation that can be possible into the material without failure, without cracking. So this is about this strain hardening or work hardening. Because of that only this all things are required. So see here, now when we talk about this percentage of cold work is goes on increasing, so definitely as I told you, because of this cold working, internal residual stresses are set into the materials. These are nothing but the energy pockets or bundles available into the material because of the straining. And please remember that whatever the amount of energy we supplied during the straining of the material, during working of the material, out of that 10 to 15% of energy get stored into the material, and that stored into the energy into the material during the working is nothing but our internal residual strains or stresses. These are get relieved here. Okay, and because of that, because of this internal residual stresses, because we know that material properties are very sensitive to the crystal structures, and because of this internal residual stresses, the properties like there is increase in the electrical resistance of the material. So if I show here the because of this cold working, internal residual stresses are there. Because of that we are having the electrical resistance of the material is goes on increasing, and there will be decrease in corrosion resistance. There will be decrease in the decreasing the corrosion resistance, or you can say this chemical reactivity goes on increasing because of this cold working. When the cold working goes on increasing, these are the various properties which are affecting like this properties on y-axis. Okay, this is about the cold working. Now see, if I talk about the hot working, so hot working simply here in hot working there is no any strain hardening or work hardening phenomena is there, because material is heated above its recrystallization temperature, and above recrystallization temperature, that means what, new grains are going to form, and as temperature goes on increasing, the grain size, definitely these grains are grow, and when the grains are growing, the ductility, when the grain size is increasing, ductility of the material goes on increasing, and अगर ductility बढ़ रही है तो definitely deformation क्या होगा, बढ़ेगा. We'll get the maximum deformation, that is we are having the good formability, isn't it? So इन केस ऑफ हॉट वर्किंग, नाउ कोल्ड वर्किंग के बारे में बहुत बात कर ली. हॉट वर्किंग में क्या है, ये स्ट्रेन हार्डनिंग जो हो रहा था कोल्ड वर्किंग में, इट इज नाउ गेटिंग रिप्लेस्ड बाय डायरेक्टली रिक्रिस्टलाइजेशन. सो नए ग्रेन्स क्या हो रहे, बन रहे, एंड बिकॉज एट हायर टेम्परेचर्स दिस ग्रेन्स आर going bigger and bigger, which will increase the ductility of the material, and when the ductility goes on increasing, formability is very high. So here the yield strength of the material is coming down. Please remember, the heating the material above recrystallization temperature decreases the yield strength of the material. Now material can be deformable, material can be formable with a minimum stress. Okay, yield strength of the material goes on decreasing. The yield strength of the material goes on decreasing as you are working it above recrystallization temperature. See, sigma y of the material goes on decreasing. So see here, in case of hot working, we'll talk about the hot working. Strain hardening replaced by recrystallization, and as temperature increases, the grain size increases, and that is ductility of the material increases, that is increase in formability increases. So material now easy to deform. Material is now easy to deform. Okay, if material is easy to deform, that is what is in stress strain curve, the yield strength becomes down, isn't it? Jo stress, it was initial sigma y for yielding the material. Now easy for deformation, the sigma y decreases, that is heating the material above RCT, recrystallization temperature, decreases yield strength of the material. Yield strength, that is sigma y of the material, and deformation is easier. So this is in case of hot working. और यहाँ पे strain hardening नहीं रहा. So if you want to enlist the major differences between the cold working and hot working, let us point out these difference. If I write here the cold working and here it is hot working. So if you want to write the difference, let us write the first difference. The definition: working below RCT. The first difference here, working above RCT. Okay. So here microstructure क्या दिखाएगा? Microstructure will show distorted grains, distorted bent grains. Okay, so no change here in the microstructure. Okay, so here the defect densities are present as the distorted grains are there. Defect densities कौन सी होती है? These are nothing but the imperfections in the crystal, like we are having one dimensional, two dimensional, three dimensional defects, that is point defect, line defect, plane defect. Like point defect में क्या है? Vacancy है, substitutional है, impurities are there. Okay, then in line defects we are having the dislocations. Okay, like that, because of this defect densities, that is defect densities are present. For example, I will write here point defect, line defect, then surface defect. These are the defect densities, and because of that, the density of the material, there is quite low decrease in the density of the material. Therefore, there is decrease in density of the material. जनरली यहाँ पे हॉट वर्किंग में ऐसा कोई चीज ही नहीं, राइट? सो देर इज नो डिक्रीज इन डेंसिटी ऑफ द मटेरियल, isn't it? So cold working में क्या है? There is a strain hardening phenomena. Strain hardening is present, and if you want to define in simple word what is hot working, so hot working में क्या है? That is hot working plus इसमें क्या है? Recrystallization. Recrystallization. Because of strain hardening is there, we need to supply the maximum force or load or stress. Okay, so here the forces or power consumption is minimum. So as forces and loads are higher, power consumption is also higher in case of this cold working process than the hot working. Next, if I want to write about the handling of material, handling of component or parts is easy in case of cold working because heating below RCT. Here the handling is difficult. In hot working, handling is difficult. Okay, that is the important thing. Then see, in cold working, as we are doing the work below the recrystallization temperature, so no shrinkage forces. Okay, so definitely dimensional accuracy is very high. Dimensional accuracy is high, but here above RCT, so at higher temperatures we are working on the material, so of course shrinkage will be there, shrinkages will be of course there, and that is the reason why the dimensional stability or dimensional accuracy is less compared to cold work component. So here dimensional accuracy is low. If you see the coefficient of friction in cold working, it is 0.1, and in hot working it is 0.6, 0.5 to 0.6 in case of hot working. In cold working there is no scaling or rusting of the component, no scale formation here, no scale formation in case of cold working on the component, but here yes, at higher temperatures you are working on it, so scale formation is there, is present in case of the hot work components. If you talk about the plant, the costing of the plant for this cold working is less compared to the costing of this plant for the hot work components, because here above RCT we require the heating of the material, of course the furnaces and all things are there.